Well, hi, good morning. Thank you for joining me in my shop here for day 2 with this radio. And what I'm aiming to do today is get rid of the hum. Should be fairly straightforward to do. And then assess the radio with all of its original parts after that and see, does it work at all, or how well does it work? And have some fun that way. So the capacitors I want to change are these 2, which are actually 4. There's actually 3 here and 1 there. I'm going to change them all into 47 microfarad 160 volt capacitors, and that should do the trick. That should do the trick getting rid of the hum. Just want to take a quick look at the schematic to be sure what I've got in my head is correct. And here's 3 of the 4 capacitors. These are in the power supply, and they're all grounded to the chassis. This indicates to the chassis, to the case. What is the difference here between the case and the chassis? Next time we look on the radio, I'll show you there are all these connections are made to the chassis. Chassis? Case? What's the difference? The last capacitor is up here, and it's also got its negative hooked up to this. I just call it this. It's definitely the chassis. What is this over here? Okay, onward. So I mentioned that there were many connections down to the chassis. It's not hard to start spotting them here. The shielded wire, the shield is soldered down. The negative from this capacitor is put on the band. The band is riveted to the chassis. You can see connection right here, 2 capacitors. This capacitor is attached to this little plate. And this capacitor, well, I don't know what it's doing. It's going up, I don't know what. Going up here. Maybe that's the rectifier too. Not sure. There are like these terminal strips are attached to the chassis. They're riveted down. The rivet goes to the center terminal. Center terminal is being used. Same sort of thing over here. It's an end terminal that's riveted down to the chassis. There's just all kinds of chassis connections here, all over the place. So what's the story on that one? See, these are all to a lug, which is riveted down to the chassis. All over the place. So what exactly do they mean on the schematic? I don't quite follow yet. Okay, but not too much of a concern with doing these. This black wire is coming over to this terminal. This terminal is tied to this ground lug right here. So both these are just grounded, like in the ground. I'll have to use the word grounded. I don't like that word, but I have to use it. Okay, I'm going to put in the capacitors now. Okay, I went to look at the rivet down here. It turns out it's not a rivet, it's a screw. So that's pretty strong evidence of these 2 capacitors being replacements. Another interesting thing about it, there's one lead on this capacitor is not being used. Red, 40. So I guess it must have been a red wire coming off here too. So, okay, all evidence that it's already been replaced. At least that one. 40, 40, 20. Okay, I'm going to just cut the wires here. There's my bundle of capacitors. I'm going to solder in here. Good. Okay, there they are, a little bundle of capacitors installed, and I even double checked them. Turn this guy on and see what we get this time. Need to put on some kind of antenna here. Well, we won't worry about the antenna. I'm not sure it's going to be receiving anything just yet. Okay. Volume is down. Plugs in. Switch is on. Here we go. I did all those capacitors, so keeping an eye on the dim bulbs. Big deal this time. Here we go. Perfect. Perfect. We're still on the broadcast band. Well, there's no hum coming out of it. Oh, I spoke too soon. The dim bulbs anymore. Now again, this is plugged into an isolation transformer. There's nothing grounded attached to the radio in any way, so I can get away with doing this without taking too much risk. But if this were plugged in a regular outlet, I'd have to get a voltmeter out to be sure of anything. What do we hear? We hear a radio that works. Okay, works with no antenna. A lot louder at this end. Okay, let's stick an antenna on it and see what we get. In my imagination, I still hear a little bit of hum. Now, again, as soon as I put this connection on, the unit is no longer isolated. And I don't like this type of radio. Okay. Doesn't do anything. Let's just put the antenna side on for now. I looked underneath. All these leads had capacitors protecting them, but I'd have to look more closely to be sure of what's going on. That screw goes right into the chassis, so the chassis is on the screw here. Just trying to be as careful as possible. You think they would make this so you can't get a shock off it, so you would think. Okay. Now the thing is, the antenna is not switched on. I have to go switch on the switch. Switch on the switch. Okay, for what it's worth. And there's definitely a hum coming from this radio. Here we go. Station right there. Okay, let's go back. Let's attach. I'm going to attach. I haven't got the antenna ground connected. Let me connect that and see what happens here. There's a Canadian sports channel talking about hockey. Surprise. This is a tough station to receive in my shop here. Usually there's noise right on top of it. This is 680. Maybe that's, maybe that's 740 based on the dial here. 590 is just about in the right spot. Okay, let's try to see if there's a French station right in here. Wow, that's really surprising. It's really picking it up. Wow. Of course, we're using the outdoor antenna. There's no indoor antenna here at all. There's no loop antenna with this radio, so maybe my outdoor antenna is better than I realize. And we shouldn't pick. Maybe you might pick 1010. No, 1010's down here. 1010. Looking at the wrong dial. No. Okay, well that's pretty good. That's really good. Now we'll try a short wave band. We have basically what I would call a long wave band, but it's really not the right term for it. Police band is actually the term. 1.7, just above the AM radio band, up to 5 megahertz. There won't be anything there, but let's just whip through it really quickly here. Okay, we're on that band. Sounds like it's working. Two, 3, 4 megahertz. Can't get to the top because this wire is still in the way here. Okay, no surprise there. Next band. Starting at the top. Not getting any reception out of this. Dirty switch problem. Oh. Okay. Oh. Lots of sensitivity in this radio. Okay, so where are we? We are on 10 megahertz now. .3 is coming up.
En casa, busca en línea. Hay tremendos recursos para ayudarnos a profundizar el estudio de la Biblia. No hace falta decir que los creyentes deben comprometerse a creer y obedecer a Yahweh con fidelidad y consistencia. Pero parte de esa...
That's going to be it for this band. We won't hear any more. Okay, we'll go to the top band. 13, 14. There's an overlap between these bands. Tricky to tune, especially with a tiny little knob I'm hanging onto here. So strong station usually at 15,770. Okay, now we'll switch it over to CW and see if it produces a tone. Yep. Very good. Another switch here is noise limiter. Not sure what this is supposed to do. Mostly take out what would be considered ignition noise. Ignition noise. Speaker and phones. Yep, speaker goes off. And receive and standby. Now I hadn't fooled with this at all. I just left this sitting here in the middle of nowhere. This should probably be on 0 when you're trying to use this scale accurately. So we're about 15, well, pretty close to 15,770 here. I would say 770 would be about there. Let's see if we can find the same station now. Can you leave this at 50 and use it as a fine tuning adjustment? What's the problem now? There's no problem. Well, I don't know. Hey, I'm disappointed. What am I supposed to do with it now? Change all those parts in there when it's operating like this? We can make a few special tests to look for very specific problems in this radio. Some of them are not particularly audible. You wouldn't necessarily hear them. And we can do that mostly around leaky capacitors. See if any of those problems exist in the radio. But wow, just a few. Wow, that's great. That's really, I wasn't quite expecting this kind of result. Very good, excellent. Before I start poking around here, it's be a good idea to review again just how they're handling this hot chassis situation with this radio. So out the back here are the 3 antenna terminals. One of them is marked, one of them is the ground terminal. But you can see that there's a capacitor attached to every one of those terminals, isolating the terminal away. Things get a little odd over here. I noticed this yesterday after finishing the video. This is the alternate speaker output, or headphones. This is a phone's output actually, right here. Now, pretty weird. I just realized the solution to the problem I noticed yesterday. The problem I noticed yesterday was there's only one wire coming here. Then there's a resistor here. It looks like brown, green, black. Small resistor between the 2 terminals. Well, how's that going to provide any kind of audio? There should be another connection here for the other half of the audio. And what I just noticed, I didn't see it yesterday, is there's a green wire down here. It's done something very odd with it. Green wire wrapped around the yellow one here and then just cut. So warning bell's going off. This could be the wire that's supposed to come up here, and somebody's cut it and then just didn't want it laying around, so they wrapped it. So it would be still there, but not free. Or that's some kind of gimmick, which you know what? This is one of the IF cans right here, is it not? Yes, it is. This is one of the IF cans. The other one is right up under here. So that's quite likely a gimmick, which is a form of capacitor, usually involved with, I'm going to forget the term for it now. Yeah, I've forgotten the term. Usually involved with a term I've forgotten, so I won't worry too much more about that, but I won't fiddle with that wire until I know more about it. My first assumption was it was supposed to be up here. You know, I'd be tempted to get in there, untwist it, and solder it here. I don't care about these outputs, so I don't care. So, but that means this output is connected solidly to this wire. Where's this wire going? This wire is going all the way around to the switch over here, which is the speaker switch. Well, I'm not sure I want to chase it any further than that for now. Yeah, actually, looks like, yeah, I'm not going to bother with it. That's the speaker terminals there. Speaker wire terminals. What I really want to go after, though, is the capacitor that does the grid blocking for the output tube. So let's jump on the schematic. Is there any other external terminals? So all these metal knobs are covered with plastic. Metal shafts are covered with plastic knobs, so you can't touch the metal. Well, how's this ever isolated from the whole cabinet? How can that be? How can that possibly be? There were screws going through here and there. Still a mystery. Okay. Grid blocking capacitor for the output tube. Okay, output tube is here. Grid is there. Capacitor is right there. Oh my gosh, is there any chance we can read the numbers on something like this? Bad photocopy. C20 something, 0.01. Pin number 6. Well, we can find this in the radio, that's no problem. Pin number 6. So we want to look at the voltage. Well, what are they doing here? They have a noise limiter switch. So yeah, this looks like a spare diode down here in this oscillator. Yeah, 12SQ7 is typically a triode with a couple of diodes. They're utilizing one diode as the sort of a clipper or limiter. Limiter would be, yeah, limiter's the right word, limiter. So that's how that's working. So with this switch open, it doesn't make any difference. They got a big resistor here. And the voltage here, is it stated anywhere in the radio? Anywhere at all? Well, we can guess it's about 120 volts DC. So this capacitor has 120 volts on this side, positive. We don't want to let any of it get over here, because it'll build up on this grid. The charge will build up on the grid and cause a grid potential change and become more and more positive than what it should be. The grid bias on this tube, we'll look in the book. This is the grid bias resistor. So what they're doing here is they're a little bit of a trick. Rather than make the grid go negative, they've made the cathode go a little bit positive. So the voltage between the two of them is in a proper bias relationship. Can I say that? So it looks like 180 or something here. I can't really read it. Pin 6 is the important thing we need to remember. Pin 6. How long can I remember that? So we'll take a 35L6 here. 35L6. Pin 6. Huh? Pin 6 is not there. Pin 5 is the grid. Maybe I didn't read it right on the 35L6. Am I nuts? Let me just double check here very quickly on my own. 35L6. Sure looks like pin 6. I don't see how you could see that that's pin 5. 35L6 GT. 35L6 GT. Well, I don't know. We'll find out when we look in the radio. We'll be able to figure it out, I think, what's going on. So, what kind of bias does this tube normally run with? Typical operation, fixed bias or cathode bias. So if we look at cathode bias resistor is 180. That's kind of what it says on the schematic as best I can see. There's the bias voltage, one for fixed bias, minus 7.5 volts. So that's kind of what we should be looking for on the cathode. Positive 7 volts or so. So 7 volts on the cathode is the same thing as minus 7 volts on the grid. The grid should be at 0 volts, but if it's not, it's maybe pushed positive. Now, I was looking carefully to see about how things are grounded. Still a mystery in this radio. We're going to use this meter over here. Ground it in here. On a ground terminal nervously. So I do have another ground on here now. I have a ground attached to the antenna ground through this capacitor. That's going to be better. Okay, output tube is where? Where's the output tube? Output tube is sitting here. Of course, this is the cathode bypass. So I just go like that, get the cathode reading. Should see a positive reading over here. I got the have my meter center zeroed for some earlier work. So just practicing now. So cathode reads 7 volts positive. Grid on 5, and they've put a resistor in here right on top of the key. The key to the whole thing. I just can't even get the slightest look at it. Okay, well, we know the cathode is where this yellow wire is. So that being the cathode, 35L6. So we know cathode is pin number 8. So if that's pin number 8, then the key has to be under this end of the resistor here. It's just... well, I like to get a really positive look at it. So they've grounded this pin. Did I close the book again? Okay, so if that's 8 and this is 1, no connection. So 1 is a place you can just make connections, and that's what they've done. They just used pin 1 as a terminal to make connections. They actually grounded that pin. Okay, all adding up. So okay, so if that's 1, 2, 3, 4, 5, that's a grid, and look at that. I'll be. Somebody beat me to it here. So behind this capacitor is that one. That black one. That black one is in here. It's got this original kind of covering on it. My guess is this is a replacement. 600 volt. Well, I'm not going to move it because there's a good chance it's replaced. There's going to be no voltage here. If it was one of these, I'll bet you there'd be some positive voltage leaking through. We're all set to go. Volume control's over here now. Volume on minimum. There we go. Okay, radio's on. I'm going to read the B plus voltage first on these capacitors here. Let me change the lights just a little bit. Okay, 150 volt scale. Hear that hum come up in the radio. So 150 volts, that's 85 on that one, 95 on that one, 110, 112. And okay, we'll look at the look at it here. This is the bias voltage, which we'd expect to be around 7 volts. So we're on the 15, that's 6 volts there, and we're not on full power. Better put it on full power and do this whole thing again. Okay. Bias voltage, just under 7. And now voltage on the grid, this, we got the volume turned.
Nicholas and Helena Rory,
wasn't quite expecting that. And grid voltage. Okay, we'll make this as sensitive as we can. 1.5 volts, full scale. Oh, must have bumped something there. The problem is I got to look in 2 places at once, and I don't want to be touching the chassis with my hand when I do this. So steady my hand. It's a teeny tiny voltage here. Teeny tiny voltage. Is that of any consequence? So I did a radio a little while ago, and I did 2 these blocking capacitors to 2 grids, and one of them went to 0, the other one stayed up just a little bit like this. So I don't think that's much to worry about, because really it's fighting the other bias voltage, and it's obvious who's winning. The almost 7 volts is going to win over this tiny little piece here, which is almost nothing. Okay, that's good. I never did do the B plus again, just out of interest. Here we go again. This was the big guy here. 130. Okay, it's all there. That's pretty good. So the hum is, it's quite likely the hum is coming from one of the tubes. I don't think it could be coming from the power supply. Not with all this capacitance here. Well, this is in really good shape. There's not much left for me to do here. I have to find something wrong with it. I don't like doing stuff for the sake of doing it. I wouldn't change all these capacitors for no good reason. We need to find performance issues. This is another one that looks like it was put in extra. And this one doesn't look all that healthy over here, but that's not much of an indication of anything. Why don't we find out what these are doing? This one appears to be across the power line. This one, yeah, we should try to figure out what that one is. Check it out. Okay. Well, maybe I found something interesting here. Now, I don't want to forget this is still switched on. Just looking for a good pointer. I'm interested in this capacitor because it looks weird. And this one doesn't look like it's original. This looks like a replacement. So this is the rectifier tube here. This guy is hooked up to pin number 2. This guy's hooked up to 4. What's on pin 2? If we look at pin 2 on a 35Z5, pin 2 is a heater. It's one of the heater connections, 2 and 7. Pin 4 is not present, no connection. So what exactly is going on with pin 4 there? 1, 2, 3, 4. I'm not sure, because it's just a connecting terminal. So somewhere on the schematic I saw a 470 capacitor. Yeah, I gotta look. I'm a little confused here. Definitely. Okay, I got a better version of the same schematic here. We can read it a little bit better. And here's what we're looking at. So this is pin 2. On pin 2 there's a capacitor going to ground. Pin 2, there it is. This is the one, this is the paper one to the right of the tube that I think looks bad. The other one is connected to terminal number 4. You see 4 is not represented here. So it's not clear what that one is. Okay, I think I'm going to change this capacitor here without knowing for sure that it's bad. Maybe we can, well, I'm going to change it. Looks like it's got tape on it. Dumont 0.025. 600 volt, 0.025. And the arrow, pretty sure the arrow is pointing at the outside foil end. It's very odd. It looks like this is a second label. Looks like there's a label on top of a label here. Funny. 0.025. We're going to test it on this capacitor checker. Now the schematic says 0.02. Capacitor says 0.025. Looks a little odd compared to the other capacitors. Maybe it's a replacement. I don't know. Okay, so I'm going to put 50 volts DC across this capacitor. If no current leaks through it, then the eye will look like it looks right now, with this open pie at the bottom. Piece of pie missing. When I first hit the switch here, this will snap closed for a moment while the capacitor charges, and then we'll see what the leakage is. Here we go. Now that came right open. It's a 600 volt capacitor. Wow, it's not doing so well at 150 volts. Wee bit leaky. Nothing too serious though. I think in the position it's in, a leak like that wouldn't have mattered. So I'll put a 0.02. Let me just measure its capacitance here. 0.02. Okay, now I turn this dial until the eye pops open. Okay, it's kind of trying to open right in that area. Yeah, so the eye should pop right open, but it's not. That's an indication of a leaky. It should be here at 0.02 or 0.025 would be here. But it's reading as if it's a bigger capacitor. It's another indication of a leak. You can't measure the capacitance of a leaky capacitor. Okay, we'll put another one in. Okay, got the new capacitor sitting there. Now I'm kind of interested in big capacitors. Any big guys in there? Any big ones in there? Yeah, there's one right here. This is a 0.25 capacitor. It's a big honker. Let's find it on the schematic. I already know where it is on the schematic. So one of the things of interest in a radio like this is how are they dealing with the screen. Here's a screen here, a screen grid. It's being fed from this line. So is there a capacitor on this line that is responsible for quieting the whole thing down? I look around for such a capacitor. There it is, right there, 0.25. That's the same one I just pointed to in the back of the radio. So this guy's pretty important. If this capacitor is not there, then there is a connection between all these tubes, and they can pass signals back and forth through this connection right here. Basically the B+ connection really is what it is. So in order to quiet it right down, it does connect straight onto a filter capacitor down here, but these guys aren't so good at RF. So to improve the RF, decoupling is the proper term here. You'd want to put another capacitor in, a regular style of capacitor, and a fairly large one, 0.25. So we're going to change that one, 0.25. Okay. The new decoupling capacitor in here. You know, this is called a decoupling capacitor because it's preventing the coupling or the connecting between different stages or circuits in the radio. But you don't want them to be coupling. Okay, hey, that was hilarious. Now, we're going to test the capacitor I took out. See if I just wasted some time here or not. So if this guy was leaking a little bit, I don't think it would make much difference in the position it's in. It's on the B+. You can drain microamps off the B+ without much concern, I would think. Okay, let's give it a test. 50 volts. Watch the eye. It's a bigger capacitor, so it takes a little bit of time to charge up. Well, it's mostly open. Not all the way. At 150, I have the feeling it's not going to open at all. Okay, give it a moment to discharge there. So on this machine, when you let go of this spring-loaded control, it puts a short on the test capacitor. So we'll try measuring this. We'll see what we get. 0.25 should be somewhere on here. See the eye operating there? Just swing it around a little bit. Funny how one day you can see the eye and the next day you can barely see it. So there it is anyway. Okay, and what do we got? So we're on the 0.5 scale. Really? There's 0.5 right there. 0.5 scale. So this is reading 0.4. It's supposed to be 0.25. So again, it's another indication of a leak, enough to throw that measurement device off. Throws off all my capacitor measuring guys. Okay. So probably a little bit of an improvement here, but not too much. We should play the radio at this point, make sure it's still working, and then they're going to call it a day. Volume down, switch is on, plug is in, here comes the power. Not much of a light bulb, but these light bulbs that are in the sets without a transformer, these are actually tricky to power, and that's why they're usually not very bright. The reason they're tricky to power is there's no easy 6-volt source in the radio anymore because all the heaters are in series. So they play a little trick with the heater for the rectifier tube and tap it at a point where there's 6 volts across it, roughly, to operate the light. Okay. No, that's not very good. It's pretty hummy. Oh, it's my hand. Picking up a ton of stuff. What are we on? Let's go over. Start with band 1. So broadcast band. It's good. Okay. Next band up. Next band up. Last band. Oh my gosh, this band goes from 13 megahertz up to 30 megahertz. Okay, let's try it. 13 megahertz.
Campaign. Supreme Court leaker. Vigilante campaign. Hunt down. You're the ones that hunt down babies that have been born. You have to kill them. You're the ones engaged in a vigilante campaign leading to
American politics. Oh my gosh. They can't move their, here's my opinion, shame on me. They can't move their society forward because a large portion of their society is scared of the future. I won't say more than that. $15 MHz. Anybody home? Well, we haven't done any harm to the radio so far. That's good. It's working. Fantastic. I gotta think of a few more things to do with it. Yes, great. It's fantastic. So thanks a lot for watching, and I'll carry on tomorrow with this radio.